So students, hello, welcome back. So exactly in the previous video during discussion of Kelvin Planck statement, we saw and discussed about the heat engine as an example. So now we will discuss about it in detail. So since we have already discussed that the heat engine is a device or machine which converts heat energy into mechanical work done or mechanical energy. It means any kind of machine or device which converts heat energy into mechanical work done or mechanical energy, we may assume that its function or principle is equivalent to heat energy. Not exactly, but somehow same or equivalent, or function or working process is same. Since heat energy, its function is to convert heat energy into mechanical work done. So let's discuss about it. Now basically heat engine consists of three parts. Now number one is the source, which is at the higher temperature, which is called hot body. Number two is the working substance. Now what is working substance? I will discuss few minutes later. Working substance, it means with the help of which it performs work. Number three is the cold body, which is called sink. It means after doing some work, the rest of the heat energy is generally stored, or it is just sprayed. So hot body or source is very easy. It means from which it is taking heat. Okay. Number two is the working substance. Now it is very easy. Now using which any engine or any machine generally does work based on which substance, that is either its fuel, isn't it? For example, we may take the example of a steam engine, which also converts heat energy into mechanical energy. So it uses the steam. So in case of steam engine, we can say the steam works here as a working substance. In case of any engine, isn't it? As any engine of any motor, it will use the fuel or any gas or any liquid, isn't it? Liquid gas, liquid LPG gas, or that is petrol, diesel. So working substance is the fuel on which any machine or any motor runs, isn't it? If it runs on electricity, then obviously in that case, yes, then its working substance will be electrical energy. So in case of any machine, any heat engine, basically its working substance means to say through its working substance it is fuel. It may be oxygen, liquid nitrogen, any air or gas recombination. So its working substance, that you don't need to be worried about, you don't need to be scared about what is the working substance. So one part is the hot body, which is called source, which is at the higher temperature from which the heat engine takes the heat. Then with the heat energy, it does some work. Its working substance, that is its fuel, does some work. Then after doing work, the rest amount of heat energy it transfers to the same, that is cold body. Then we may assume it at the surroundings, isn't it? Doing some work, then the rest part of energy is generally dissipated or generally transferred to the surrounding. So in this way you can just understand, okay, so that you can understand easily. So the heat engine, the source, hot body, then doing some work, then the rest of the part, the heat is H2. So hot body, the source is at the temperature, is at the heat, since its heat is H1. So the source of the total amount of heat of the hot body or source is H1. Using that heat energy, the working substance fuel do some work, that is mechanical work. Then the rest amount of heat, it transferred to the sink, and the remaining part of the heat, it means now the amount of heat of the cold body 6 is H2. Now it is very easy, that is this H1 is the total amount of heat of the source or the hot body. Then utilizing that amount of heat, the working substance, whatever be there, okay, I have already discussed, doing some work, then it sent or dispels the rest amount of heat to the sink of the cold body or the surrounding. So it is very easy. H1 is the amount of heat before doing work. After utilizing this, the rest amount of heat is H2. So obviously, if we subtract this H1 minus H2, so this amount of work. So if we say that is this work which is done by the working substance. So how? So what is the amount of heat it has utilized. So it is very easy. H1 heat is used, then the rest is H2. So obviously if you subtract the rest amount of heat is H1 minus H2, it is utilized, which is used by the working substance to do the mechanical work. So it is very easy. So work done W is equivalent to, according to first law of thermodynamics, it is nothing but using the first law of the very basic form, general form of first law of thermodynamics, we can easily say this, using this heat energy is H1 minus H2, which is just used or expend. So expending this heat energy, it is used to perform the work done. So this work done W is equal to H1 minus H2. Very easy. H1 was the initial heat. After doing some work, the rest heat is H2. So obviously, the difference between these two heat energy is equivalent to the total amount of work done, which is done by the working substance of the fluid. What is the efficiency? Efficiency is generally measured by the ratio of the work done, the amount of work done by the working substance divided by the amount of heat it is given. That is exactly like the source, that is input. So total amount of work done by input heat energy. So W is equal to H1 minus H2 divided by H1 through calculation. That is, we can write H1 by H1 is equal to 1 minus H2 by H1. Now since it is cold body, so whatever be the heat energy at the source, after doing some work, some amount of heat energy will be used up. So obviously the rest amount of heat energy, which is generally transmitted to cold body or sink, or you may assume just in the surroundings or in the environment, obviously it will be always less than that of the source heat. So since always H2 is less than 1, so from this equation we can say efficiency is always less than 1, just like pulley or anything, isn't it? It means always less than 100%. Okay. So now try to remember the statement, that is the Kelvin-Planck statement, the first limitation of first law of thermodynamics, or the first statement of the second law of thermodynamics. That is, it is impossible for any self-acting machine to transfer all amount of heat entirely into what? Because of this. That is, since H2 is always less than 1, so efficiency is always less than 1. Isn't it? That's why it is exactly applicable or consistent with Kelvin's Planck statement, first law of limitation of the thermodynamics, or first law of, or first statement of second law of thermodynamics. It is impossible. So that's why any machine cannot convert all amount of heat totally into work done, because you can see from the equation H2 is always less than H1. So it means it will be always less than 1. That is 100%. So that's why any machine, any self-acting machine, cannot transfer all amount of heat entirely into work done. Clear? So this is heat engine.